Backpropagation, how to pick activation functions. Imagine trying to teach a robot to recognize your face. You need to give it the right signals so it can learn. That's where activation functions come into play. They are like the decision makers inside neural networks. They help the network decide what to pass on to the next layer. Choosing the right one can make or break how well your model learns. Let's start with the basics. Activation functions introduce nonlinearity into the network. Without them, no matter how many layers you add, the network would just behave like a simple line. That means it couldn't learn complex patterns, which are common in real-world data. So, nonlinearity is a must-have. Next, think about how the function behaves during backpropagation. When the network learns, it adjusts weights based on gradients. Some functions, like the sigmoid or hyperbolic tangent, can cause the gradients to become very small in deep networks. This problem is called vanishing gradients. When gradients vanish, learning slows down or stops altogether. That's why functions like the rectified linear unit, or ReLU, are popular. ReLU keeps gradients strong for positive inputs, helping the network learn faster. Variants like leaky ReLU also help by allowing small gradients for negative inputs, avoiding dead neurons. Now consider the output range. Sigmoid outputs values between 0 and 1, making it perfect for binary classification tasks. Tanh outputs between -1 and 1, which helps center data and often works better in hidden layers. ReLU, on the other hand, outputs 0 for negative inputs and a straight line for positive ones, which makes it efficient and sparse. For multi-class problems, Softmax is used in the output layer to turn raw scores into probabilities. Computational efficiency is another factor. ReLU is simple to compute, just a threshold at 0, so it speeds up training, especially with large datasets. More complex functions like Sigmoid or Tanh requiring more calculations, which can slow things down. In real-world AI tools like ChatGPT, DALL-E, or Midjourney, neural networks often use ReLU or its variants in hidden layers. This choice helps models learn faster and handle large amounts of data. For the output layer, the activation function depends on the task: Sigmoid for binary, Softmax for multiple classes, or linear for regression. Ethically, picking the right activation functions helps create models that learn efficiently and perform reliably. Poor choices can lead to models that don't learn well or produce biased results. This is especially important when AI systems are used in sensitive areas like healthcare or finance. So, how do you pick the best activation function? First, ensure it's nonlinear to learn complex data. Second, choose functions like ReLU in hidden layers to avoid vanishing gradients and speed up training. Third, match the output layer to your task: Sigmoid for binary, Softmax for multiclass, or linear for regression. Lastly, consider how much computation each function requires. Making these choices carefully helps your neural network learn better, faster, and more reliably. It's a key step in building effective deep learning models that can handle real-world problems.